Hi class, today's lesson is on polyatomic ions. So a polyatomic ion is a group of atoms bonded together that actually acts as a single ion. And what they are actually acting like is a group of nonmetals. So for example, nitrate is a polyatomic ion. Nitrate is made up of, so this is polyatomic, you'll notice that nitrate is made up of one nitrogen atom to 3 oxygen atoms. That combination is no longer considered nitrogen plus oxygen, it's nitrate. It's a nitrate ion acting as a group of one thing, okay? You'll notice that the ending is ATE. That's a common indication that you have a polyatomic ion, not always. And again, the other thing I want you to note is that the nitrogen element symbol and the oxygen element symbol are both capitalized. So in regular binary ionic compounds and the ionic compounds that we have been learning in class, a bond forms between a metal and a nonmetal. In the case of a polyatomic compound, it's still considered ionic because it is a bond between a metal and a nonmetal, but this time the nonmetal is actually a group of nonmetals, okay? So it's more than one nonmetal. And you're going to recognize this by seeing the fact that the nonmetal portion of your, for example, of your compound is 2 capital letters. So that is the formula for a polyatomic ionic compound, and I see that iron is my metal, and here I have my nitrate ion, and it's going to act as my nonmetals, and I know it's polyatomic because if I look at how many capital letters are in my nonmetal, I see that there's 2. And remember, when we're writing element symbols, only the first letter is ever capitalized. If there's 2 letters, the second letter is always lowercase. So when you see 2 capitalized letters acting as a nonmetal, that is an indication right there that you have a polyatomic ion on your hands. Here is a chart of some common polyatomic ions. You'll notice the name of the polyatomic ion, including the formula and its ionic charge. Please note that the formula doesn't include the actual minus and plus signs. That's just the ionic charge included on it, okay? So when you're crisscrossing, you're not including the negative. That's just the charge part of it, okay? And here, up here, this should say charge. Let's make that the charge, okay? These are just some common ones that you'll be responsible for. I would highly recommend that you copy these down in your notes. You are now going to need your polyatomic ion chart, which is this. You're going to need your multi-charged metals chart and your periodic table when naming compounds from here on out. How are you going to recognize the difference between binary ionic compounds, which are just your regular ionic compounds formed between a metal and a nonmetal, and polyatomic ionic compounds? Well, if you're going from the chemical name to the chemical formula, check to see what the ending of the chemical name is. We are no longer going to see IDE as an ending for polyatomic ions. Okay, so that doesn't apply for polyatomic. So if you don't see an IDE ending and you see something like ATE or ITE or hydroxide was one of those, right? Then you know automatically that you're going to have a polyatomic ion on your hands. If you see an IDE ending, it's a regular binary ionic compound, so just one metal and one nonmetal. If you're given the chemical formula and you are asked to write the chemical name, well, you're checking to see if there are 3 or more capital letters. Remember, if you had a regular ionic compound, let's say sodium fluoride, for example, NaF, right? We have 2 capital letters. Sodium is my metal, fluorine is my non-metal, right? So only 2 capital letters. But a polyatomic compound, like lithium nitrite, for example, how many capital letters do I see here? Well, I see this capital letter, I see this capital letter, and I see this capital letter. I definitely know that this has to be polyatomic in that case. This is a really good trick for determining when you have polyatomic versus regular ionic compounds. Okay, now we're going to actually work on an example. Here's a chemical name, magnesium nitrate. We're going to write the formula. Okay, so we're going to do the same thing like we normally do. We're going to go through a checklist to see how to name things. Automatically, I see in my name that I have ATE. That means I have to use my polyatomic rules. Okay, so I know it's going to be polyatomic. So right away, I'm going to go to my polyatomic chart and I'm going to write down the symbol for the polyatomic ion. Nitrate is NO3. Okay, and I know that it has a charge of -1, so I'm going to write that on the top. Magnesium is my metal. I know magnesium has a charge of 2+. Notice that the NO3 is acting as my non-metal. 2 capital letters acting as a group. It is a 1 nitrogen to 3 oxygen compound. Okay, I'm going to, let's switch my color of my pen. I'm now going to crisscross my charges like normal, and I'm going to be left with Mg. And then notice what I'm going to do here. I always put my polyatomic compound in a bracket, okay? And I'm going to bring down the 2. What would happen if I didn't include the bracket was this number would look like 32, and that's not correct. You don't have 32 oxygens. You have 2 nitrate ions, okay? So actually you have 2 nitrogens and 6 oxygen here, okay? So here's my formula. I know I can't reduce it any further, so my formula for magnesium nitrate is MgNO3 2. Okay, next we're going to work on zinc phosphate. So again, I see ATE. I know it has to be polyatomic, so I'm going to write my element symbols first. Phosphate is PO4. Zinc has a chemical or an ionic charge of what? Let me just find it on my periodic table, 2+. Phosphate has an ionic charge of 3-. And again, you're going to have that polyatomic chart next to you while answering these questions at all times so that you know what your ionic charges are, because you cannot find them on the periodic table. I'm going to crisscross my charges. So the zinc is going to get this 3. You lose the negative, you just write the 3. My PO4, I'm always going to put my polyatomic ion in brackets, and then the 2 is going to come down. I can't reduce 3 and 2, so I know that this is my finalized formula. Zn3PO42. And again, note, capital letter, capital letter, capital letter. Good indication it's a polyatomic ion. Okay, our next example is copper 2 nitrate. And notice that you have a Roman numeral, so you know this is one of those multi-charged elements, so I have to be careful with my charges, which one I choose. So the first thing I'm going to do is write down my element symbols as usual. Copper is Cu, nitrate is NO3. Now, nitrate has an ionic charge of 1-. Copper has the possibility of being a 2+ charge or a 1+ charge. I know based on the Roman numeral that this has to be the 2+ charge, so I indicate that in my crisscrossing here. Now, let's crisscross our charges. That goes down there, that goes down there. So this is going to become Cu, the 1 comes there. I'm always putting my polyatomic ion in a bracket, and then the 2 comes down. So copper 2 nitrate is CuNO3 2. Let's try another one. Okay, our next one is naming. So I have FeNO3 3 here. So The first thing that I'm going to note is that it's polyatomic, so I know my ending has to be what the ending of the polyatomic ion is. NO3 is nitrate, so I'm going to write that here. So I know my ending is going to be nitrate. I don't do anything, I leave it as nitrate, okay? Now, I've noticed that my metal is one of my multi-charged elements. Iron can either have a charge of 3+ or 2+, and that is going to impact how I name this compound. So I have to work backwards to figure out which charge was actually used. I know that nitrate has a charge of 1-, okay? So there would have been a 1 up here, and that means this 3 had to come from the iron. So which iron was used? 3+. So when I'm naming this, and let's change this coloring, it's going to be, oh, I'm doing this wrong. I'm about to write the symbol again. Let me erase this. Okay, so I'm going to have iron 3 nitrate. Okay, that is the name of that chemical formula. So you have to be careful. You still have to pay attention to when you have metals that have more than one charge. You have to have now all three. You have to have your periodic table. You have to have your chart of multi-charged metals. And you have to have your polyatomic chart with you when naming compounds from here on out. What about this one? CuSO4. So let's name this compound. So right away, I notice my metal is one of my multi-charged metals. So copper can have 2 charges, 2 and 1. So I have to work backwards. So I see I have copper and I have sulfate. I'm going to go back to my chart. I'm going to see that sulfate actually has a charge of 2-. Okay, so there was actually a charge of 2 on sulfate. So I don't see that in my chemical formula, which means that this formula has been reduced. So if it's now at a 1-to-1 ratio, that would mean that copper, which has the possibility of having either a 2+ charge or a 1+ charge, most likely had the 2+ charge, because when I go to crisscross these charges, they're going to cancel out. So this is going to become Cu2SO4, which would then reduce to CuSO4, because the 2 would be reduced by 2. Okay, so the charge on copper that was used was 2+. So now when I go to name this, just give myself some room here, I'm going to name it as copper 2 sulfate. And sometimes you're going to see sulfate with an F, and sometimes you're going to see it with a PH. It doesn't matter which way you spell it, okay? I hope this helps now. I'll leave some practice problems for you.